Welcome, dear audience, to our second Co-Versatile webinar. I hope you enjoyed already the first webinar. If not, just a reminder that you can, of course, have the replay playing in our platform. But today we are going to talk about resilient supply chain. First of all, I would like to introduce myself. My name is Christian Bölling. I'm the director of the EIT Manufacturing Innovation Hub Central in Darmstadt, Germany, and we are part of the project team of Co-Versatile. So today we are talking about the question how to reconfigure and re-evaluate supply chains for better resilience at time of crisis. And unfortunately, we have to say that COVID-19 pandemic crisis is back. Today in Germany, we have 75,000 new infections. The number of hospitalization is rising up, and therefore it's as actual as it was during the last year. So therefore, we are happy that you joined this webinar to learn more about how Co-Versatile can support your business to react on this crisis. First of all, let me introduce you to today's webinar. So after the introduction, we will have four different slots with topics on supply chain resilience, on lessons learned, on risk analysis for re-establishing resilience in the future pandemics or future crisis situation. And then we have part of supply chain simulation to increase the resilience. We will close the session with a panel discussion, and here is your opportunity to actively take part in our webinar. So if you have any questions, any remarks, any comments to the presenters and to the content, so please use the Q&A box on the right-hand side, ask your questions, and we will include them into our panel discussion at the end. And then we expect the closing around 11:30. So before we go into the topics, I would briefly introduce Co-Versatile. So Co-Versatile is one of four projects which were granted by the European Union, European Commission, to repurpose manufacturing for vital medical supplies and equipment. You can see next to us we have the project Eureka, Reservist, and Impure. So we together built a cluster of projects which exactly deal with the manufacturing reaction of manufacturing industry inside this crisis situation. So that means innovative and rapid health related approaches. That also means quick response to challenges and managing the pandemics. So more in detail about Co-Versatile. So it's coordinated by Starkey from Hungary, and it includes 21 members from all across Europe. You can see the distribution here. And we have included all necessary organizations, being from industry, being from research, being from innovation clusters, to deliver the results we have promised and we would like to show you today and in the upcoming two webinars. So the duration of the project is 24 months, so now it's half time, so it's time to reflect what we have achieved so far. So what is Co-Versatile about? When we look in the content, or first of all, I guess I would like to show the next slide with the webinar series. I just mentioned that next week we have the scale up of production in a webinar, and in December 9th we have the workforce ramp up. So you're welcome to join those webinars. If you miss one of them, again, you can always have a look into the replay. So before handing over to my colleagues, I would simply sum up what the Co-Versatile is about. So we deal with adapt manufacturing processes for upscaling of production. We have the topic of reconfiguration and re-evaluation of industrial supply chains. And we have the topic of workforce ramp up. And all three are inevitable necessary to deliver a rapid response to such a crisis situation we face with COVID-19. And therefore, I'm very happy that we today can show you already first results about our project. And for that purpose, I would already start and introduce our first speaker of today. That's Elena Revilla. Elena is professor and department chair operations management at the IE University. Elena is a pioneer in study of organizational learning, and her primary research interests are organizational behavior in context of operational and supply chain management. So, Elena, you will today provide us with the topic of supply chain, resilient supply chains, and you have worked on that in our project through the last year. So we are very pleased to see what the outcomes are.
Okay. Thank you, Christian. Thank you for these introductions. And thank you, all of you, for being here today. Before speaking about resilience, we have to start talking about this disruption. Disruption is a breakdown in the manufacture flow of goods and their delivery to customers. In this slide, you can see a different behavior in the level of disruptions before and after COVID pandemic. Before COVID, the level of disruption was very low. It doesn't mean that we didn't suffer any disruption. We all remind a famous disruption as Japan's tsunami, or some floods in Asia, or even the United States September 11. But they keep the level of disruption very low. However, after the pandemic, we can see that the level of disruption has increased a lot. In some way, it seems that disruptions are here to stay. In our next slide, we'll see that there are many factors that had a significant disruptive impact on the supply chain operations. The first one is the COVID pandemic, but it is not in that. It is not only that. There are other factors as cyber attack, price fluctuations, standards and regulation, economic slowdown, and environmental hazards, tariffs, or trade wars, and even the Brexit. Disruption, why is important? Because disruption is linked to a shortage. In our next slide, you will see that now the shortage is in the news all the time. We are watching different kind of shortage, reading the newspaper. We can speak about chip shortage, energy shortage, raw material shortage, global container shortage, capacity shortage, and even truck driver shortage. What started being as a shortage in the medical suppliers now have spread to to many different industries. What are the consequences of this? In our next slide, we will see that these shortages are increasing the price, decreasing the revenues. Now it's quite, we see how the price are increasing, the costs are rising, and we also see that there are business of factory that had to be closed because of that, with a poor asset utilization. We have stock outs, but also at the same time, excess of inventory, higher cost of capital, shareholder lawsuits, turnover, management and personal turnover, loss of reputation, and also a negative publicity. And why? Why that is happening now? What are the reasons for that? In our next slide, we see that now the level of risks are increasing a lot, and they are creating an imbalance inside the supply chain. During the last decades, companies were searching for efficiency for the supply chain, and that make the supply chain more global, even more complex, and they rely too much on outsourcing. Sometimes they have only a single suppliers for some critical components. Sometimes there are over concentrations of an operation. They are more linear because of the just-in-time, and they have a little stock in their supply chains, and that make the supply chain very rigid and tight. It means that the supply chain break easily when something happens. And in my next two slides, I'm going to show you what I wanted to say with that. In this slide, you can see a plane where any of this part is produced in different parts in the world. We can see Australia, Japan, France, Sweden, different places in the United States. Is all over the world. We are missing different cultures, different laws in the supply chain. And if something happens in any part of the world, it could be probably that the plane cannot be built. And in our next slide, also show a little bit the level of complexity of our current supply chain. And here is, in our next slide, we will see that here is where resilience come to the stage. Resilience introduce balance and neutralize part of these risks that the supply chains are getting. Why? Because the resilience minimize the impact disruption because of their resistance capacity, and because also work on the recovery, returning to supply chain to functionality once the disruption has occurred. And at this moment, I would like to stop here a little bit and to ask a question to the audience. I would like to know, what do you think are the most important factors that has impact on the disruption of your supply chain operation? I would like to know your opinion and to share with the audience. What do you think about that? What is the factor with the biggest impact on the disruption of your supply chains? Please, we have 1-2 minutes to answer these questions. It could be lack of preparedness. We are not ready. We don't see the disruption coming. It could be lack of flexibility. We were not able to do different things. That was because we have only a single supplier for some of our components. Limited visibility. We are very centralized, and we couldn't to introduce or to differentiate different things in the supply chains. Maybe we have some difficulties to go to the online channel, especially for the retail, or even we rely on analog tools. The idea is to identify and to share with you what is your opinion about the biggest impact on the disruption of the supply chain. Lack of preparedness, limited flexibility, maybe lack of visibility, single source for critical components, single channel in the retail, and difficulties to go to digital tools. I'm waiting for some result to be able to share with you and in some way to introduce some kind of debate in this webinar. Again, I asking you, I think, about the biggest impact on the disruptions. Which factor had the biggest impact on the disruptions in the supply chain? Here, okay, we have the first results. I see that 50% of you think that the lack of preparedness was the most important factors, following with the 50% of you thinks that the lack of preparedness, and in a low level, with the a little bit more than the 15%, we have limited flexibility, single sourcing, and centralized procurement. And then I think there is a big difference between lack of preparedness and the other three: flexibility, sourcing, single sourcing, and centralized procurement. I hope that in the next part of my presentation, I can give you some ideas about how to introduce resilience in order to avoid these situations. I see that there is no change, and means that this are the result. 50% lack of preparedness, later on at a level of 15, limited flexibility, single sourcing, and centralized procurement. Okay, let's go to the second part of these presentations. Now we are be focused on how to build resilience. And this idea is to help companies, to help you to avoid the previous situation. We are using the lesson that we have learned from the co-versatile partners in the pandemic, in the COVID-19. The first lesson that we have learned is related with the importance of flexibility. In order to introduce flexibility in the companies, it's important to have multi-skilled workforce able to perform different tasks in case it will be needed, but also automation of the repetitive tasks. Modularity used to be a very useful strategy to introduce flexibility. Modularity means that the final product could be built with interchangeable components so that the company can adapt to meet customer needs. Multi-sourcing is also important, especially when you have one only supplier for a critical component, or you have all the suppliers of the same components in the same regions. This means that if there are some general things that happen to all suppliers, it's going to happen to the components. Dynamic segmentation is also very useful to account for changes at suppliers or economic environments. And postponement. The postponement, what do is to delay some part of the supply chain until the demand is realized. And it gets the company flexibility to adapt to the last demand. The next lesson that we have learned is related with revenue assurance. That is in the next slide. At this point, we need to think a little bit about companies are evaluating their suppliers. As I tell you before, companies were looking for efficiency. But I think we have learned that it's important to balance efficiency and resilience and to get some kind of balance between these two things. Related to this, it could be interesting to enhance inventory capability in a special situation when we have critical components with very few suppliers. It's also important to work close with the suppliers, to take care of this relationship, to treat them as partners, and to build some kind of engagement with the suppliers. And of course, just in case, it could be key to maintain a large network of approved suppliers. Our next lesson, in order to introduce resilience, is related with visibility, the visibility of the supply chain. We have learned that companies will pay attention to the first-tier suppliers. They know more or less what's going on. But most of the disruptions come from second and third-tier suppliers. It means that we need to go beyond the first-tier suppliers and to pay attention and to invest in end-to-end supply chain visibility. Related to this, it's important to also get visibility about the inventory in the supply chain. And also mapping and understanding the industry and the adjacent industry. We saw an example where the demand of products goes down and accordingly the production of that product goes down. But at the same time, the production of a byproduct, critical components in another industry goes down. It means that the price increases a lot with important effect in this other industry. Also, we learned in this pandemic in our next slide, we learn the importance of the logistics. It seems that we never, the supply chains didn't pay much attention to the logistics, but now we have seen that it's important to use or to take into account more than one mode of transportation, to analyze different modes of transportation with different routes, alternative routes, in case some port could be locked, and also to assure capacity in advance, because we are suffering problems with the capacity in the transport. And finally, one of our best lessons is related with supply chain risk management. I think more than ever, supply chain risk management is important. Any supply chain is different, and it means that the supply chain risk management should be different. It's not equal for all supply chain. We need aligned supply chain management and risk management. Risk management depends on the supply chain, the design of the supply chain. The consequences of this is that the risk management starts with the design. The supply chains have to be proactive by design. When they define the supply chain, when they define the product, which materials they are going to use, modularity, they are things that have to be defined during the design. But at the same time, they have to be reactive by deployment. They need incident management. They need business continuity plan to be ready, to be prepared to respond to disruptions. As we see, Coversatile see the importance of the risk management, and they introduce risk management in their business case in this European project. And here is when I would like to go back to the audience and to ask you another question related about resilience and how to introduce resilience in the supply chains. My next question is, which of the following areas are your supply chains, or do you expect your supply chains change in the short term to increase resilience? In which areas do you expect more changes in the short term to increase resilience? We have been speaking about the importance of having more than one suppliers, and then do you think your supply chains is going to increase the number of sources for raw material? Do you think it's important, or you will have more backup production sites? The changes would come for introducing more visibility in the second, third, fourth tier suppliers. Do you expect to increase the inventory of critical products, or nearshoring of our production or supplier base? Or, as we talk, are you thinking to introduce more logistic options in the supply chain, more roads, more transport modes. What do you think, or where do you expect more changes in the supply chain in the short term to increase resilience? More suppliers for the same components? Backup of production site? Or here I have some results, and we have the same importance for three answers. At the same level, 33% dual sourcing of raw materials, nearshoring of own productions, and consider more logistic options. It means that you are considering the logistic, that an important part of the supply chain, always to nearshoring, to have close the production facility or the suppliers, are to have more than one suppliers, especially for critical components for raw materials. Three are the most, at the same level, three are the most important changes. Dual sourcing for raw material, nearshoring, production facility and suppliers, and more importance for to consider more logistic options. And thank you very much for your for sharing your opinion, your thoughts about this topic. And we'll go for the next part of the presentation. Thank you.
Yeah, thank you very much, Elena, for this introduction to supply chain resilience. And we will have you later on again in our panel discussion to also answer potential questions. So feel free to write your question in our Q&A box, and then we will see you later on. Thanks for the time being.
Thank you.
And with that, I'm happy to introduce the next speaker as well from IEE Business School, and that's Beatriz Acero. She holds her PhD in logistics and supply chain management, and her primary research interests focus on supply chain risk management, the role of logistics in resilience creation, and you also recently added the topic of supply chain digital transformation into the field of research, your field of research, and you're involved in a lot of international research projects. Among others, it's co-versatile, and today we're going to talk about supply chain risk analysis for re-establishing resilience during future pandemic situations. So welcome, Beatriz, and the floor is yours.
Thank you, Christian, and thank you everyone for attending this webinar. So if you've been following the social media from Coversatile, and especially to all of you that attending to the first of our webinars, you are already familiar with one of the objectives of Coversatile, which is the development of a silicone mask. We all know what happened during the first months of the pandemic when masks were nowhere to be found in Europe. So what we want to do with this part of the Coversatile project is to give the tools to Europe and all the interested adopters to have a silicone mask that will be ready to be produced within 28 hours since another pandemic is declared. So with that in mind, Coversatile is developing a one-piece, biocompatible, reusable, and lightweight mask that will comply with the relevant personal protective equipment certifications and different standards. And the objective is to have a mask that could be certified as FFP2 by future adopters. To have a mask that could be manufactured very rapidly and by multiple manufacturers, we are designing an easy and quick replicable manufacturing method with a very low workforce dependency, which has been shown to be critical during a pandemic or a health crisis. And also, we are developing a mask that we have lack of external dependency from outside Europe. For that reason, we are designing a mask that is composed only by two elements. The main element, which you can see here, is a silicone carcase made with a silicone compound in which we will insert a filter in the lower part. And filters and silicones are two elements that can be found in Europe right now quite easily. So here we are showing you the supply chain of the mask. Here in the center, we have the silicone parts manufacturer. By a silicone part manufacturer, we are referring to an industry that can be found quite easily in Europe. We are talking about automotive manufacturer parts, we are talking about the aerospatial or the general industry in general. So these manufacturers can be found quite easily within Europe and in basically every country. To manufacture the mask, we by Coversatile, we are designing a max mold, which will also be produced as a prototype. This mold will have two cavities in which manufacturers will be able to produce two different size masks, one for larger, like a larger population, larger size population, and another one for smaller, medium size population. The mold is made of steel, and also it will need of a laser engraving supplier. Why are we including this step? Well, we want to enhance the comfortable of wearing the mask. So we are giving it like a velvety texture, and this will also facilitate the gripping of the mask. Then we are going to need of our silicone. We will use silicone compounders, which are companies that are again quite easily found in Europe that will procure and source their raw silicone and additives from chemical companies. And later we have the filter. The preferred option would be to go with a non-woven filter manufacturer because that would facilitate the certification of the mask as FFP2. The non-wovens filters are made of uh, two materials. The first is the non-woven material, which are going to form two of the layers of the filter. The external layer, which is the layer that is in contact with the air, and the internal layer, the layer is in contact with your skin. And between those two layers, we have a melt blow material. This is the most important and critical material of the filter because it's going to do the filtration itself. And I want you to remember this melt blow material. And then if for any reason non-woven filters are not available or are not an option, the silicone carcase is going to allow you to use any other type of filter. And we could talk about a cloth filter, a cotton, for example, any textile should should offer some level of protection there. So we've been analyzing the supply chain. We've been analyzing the design of the mask and its manufacturing process. And we have identified some risks there that could be categorized into two main groups. The first one is the manufacturing related risks, and the second one are the suppliers related risks. So let me go briefly about on these risks and also about some of the mitigation strategies that we've been working on and suggesting as part of the Coversatile project. So on the manufacturing side, we have the main risks of stocking out or overstocking. So when we were describing the mold, we told you that there are two cavities there. And the reason why we are designing a mold with two cavities is obviously to expedite the manufacturing process. So you can, in the same mold, you can have two max manufacture at the same time. One is going to be offered to larger a larger size population, and the other one to a smaller medium size. But of course, we know that we cannot divide population. 50% are large people, 50% are small people. So when we do our manufacturing, there's always going to be high risks of overproducing one of the sizes. And consequently, there is a waste of the resources and materials for the silicon carcase. So we encourage future adopters to do a careful study of the demand of the mask, for how long do they want to meet that demand, and adapt production accordingly. And the second risk in the manufacturing side is the transportation of the max itself. Elena has been previously talking about the logistics, and I'm pretty sure that you've been reading the news lately, and it's really strange the day that you don't read some news related to transportation disruption, logistic disruption. So it's very important to do careful and recurrent monitoring of the transportation situation, and always have an alternative plan. What's going to happen, what I'm going to be doing if for some reason my preferred transportation mode is no longer an option? What's going to happen if one of my infrastructures, that the port that I'm using, or the logistics platform that I'm using, has a disruption? So it's very important to have always that alternative plan. Be prepared, which is one of the things that Elena was talking about. If we go to the other big group that we have, the suppliers, we said that our mask is being designed with the idea of being very simple and have no dependency from Europe, from outside Europe. So we have the risks that have to do with the silicon compounders. We said silicon compounders are companies that can be found basically in every country in the European Union. And that's true. And we also know that the chemical companies that are procuring the raw material and the additives are also located in Europe. There are several companies here. However, these chemical companies are working at capacity, and this problem is not expected to be solved anytime in the near future. So it's very important to be prepared for that and do pre-arrangements with silicon compounders and with these chemical companies to secure the capacity, and also to secure the transportation of my silicon compound to my silicon part manufacturer. On the filter side, um, if we talk about the non-woven filters, we again have companies in Europe that are producing filters and disposable masks. And that's something that have changed significantly since the pandemic started at the beginning of 2020. So that would lead us to think that there shouldn't be any issue there. However, that's a bit misleading, because we said that one of the main materials that is required to do the non-woven filters is the melt-blown. And melt-blown filters are pretty much outsourced, and they are the suppliers are located still in Asia. So if everything goes as it's right now, yes, in the next pandemic, we will have non-woven filters company producing those filters in Europe, but they will be in big trouble because the melt-blown is coming still from Asia. So it's very important to understand the dependency of these filter companies on their melt-blown, to know, to go beyond that supplier, understand the visibility and of my supply chain. And again, it's important to secure the transportation of my filters, of my melt-blown filter, to the manufacturer. And again, if if the non-woven filter is not an option and we go with the cloth filter, there are two main things that we need to take into account. The first is that the manipulation of the filter is not that good, and that's basically because structurally the textile is not as stable as the non-woven. Non-woven filters are more rigid, so it's relatively easy to secure the filter to the mask, and it's relatively easy to have the filter fixed. It will not move. However, cloth are more loose, and that means that if it's not secured properly, there will be some gaps where the air will flow inside the mask. So that could compromise the protection. So for that, it's very important to do more, to be more careful in the manipulation of the filter, pay more attention in how to fit and secure the filter inside the mask. And in any case, we should have into account that the protection levels may not reach the FFP2, which is something that we have that's the objective, that's the target. So having analyzed the risks, we have some recommendations for future adopters of this solution, of the silicon max solution designed by Coversatile. By future adopters, we could talk about the country governments, local authorities, or big entities like, for example, the civil protection of the different countries. So for these future adopters, it's very important to think about the process design. What's the population that needs to be protected? How many masks do they need to secure to the population, and for how long do they want to secure that supply of masks? And based on that, future adopters should do the right acquisition of molds and understand that demand and adapt that pod accordingly. That leads us to make a careful analysis of the supply chain. How do I want to design the supply chain of my max manufacturing? Where are the silicone parts manufacturer going to be located? How many of them are going to be involved in the manufacturing of the mask? Where are the silicone compounders going to be located? Who is going to be doing the logistics and transportation? Pay attention to our pre-arrangements with the silicone compounders, with the filters providers, and with the logistics to make sure that once the pandemic is declared, they will have sufficient stock and they will be working with these future adopters, with the local authorities, to give priority to the production of the silicone compounders and the filters. And finally, we want to talk about certification. We said at the beginning of this part of the presentation that the objective is to have a mask that will be easily certified as FFP2. Due to time constraints, Coversatile is not going to have a mask ready certified here. But if future adopters want to offer the population a mask that is certified as FFP2, there is some work that needs to be done in advance, and they shouldn't be waiting for the pandemic to be declared to start that process. So that means that all the supply chain should be designed, the different partners should be chosen, thinking about that certification. And in any case, we believe it's very important to start thinking about some expedite bureaucracy processes. So in case there is some issue as the pandemic is done and is declared and the max is being produced, so these expedite bureaucracy processes could solve any issue regarding the certification in a very short term, namely in a couple of days. So with that, I'm finalize this part of the presentation, and if you have any question, just feel free to post it on the comment side, and we can wait until the end of the discussion and the presentation to answer those questions in the open round table. Thank you very much.
Yeah, thank you, Beatrice, for this introduction. And I guess with look on the time, I would propose that we answer those questions which may come in the panel discussion right after the next presentation. Yeah. So for the time being, thank you very much, and we will meet each other then afterwards. So then we are moving forward to the third topic of today. So supply chain risk and for the third topic, third topic of today, supply chain, resilient supply chains with simulation. And for that purpose, I welcome Saskia on the stage. Saskia is a senior scientist for SEM research and strategy at the Fraunhofer Institute for Material Flow and Logistics in Dortmund. So welcome, Saskia. You're coordinating the research for the Department of Supply Chain Engineering, focusing on supply chain management topics with specialization in risk management, discrete event simulation, and interfaces to application areas to artificial intelligence. So you are leading us through the next part of our webinar, and you are doing that not alone. So at a certain point, you will welcome Besim Bobita from Demcon. He's strategic purchaser. He has an MBA in purchasing and supply management, and his key responsibility areas include setting up supply chains for different high-tech projects, ensuring timely supply of mechanical electrical parts, and he will, together with you, design the next few minutes. So welcome both, and Saskia, the stage is yours.
Thank you, Christian, for this nice introduction. I will just talk about resilient supply chains with a simulation. So we have got within Fraunhofer we have got a simulation tool which we used within Coversatile to find solutions to adapt. So I will talk a bit about that. First of all, I just I will come to the risk which we have the risk which we have in the supply chain due to COVID-19. So we already heard earlier on from Elena about certain risks, but specific now on COVID-19, we had actually the most difficulty with the supply and demand issues at the same time. So normally we deal with risks which are either touching the demand or the supply end, but with COVID-19 we had the situation that both ends were actually were affected. So another part is also that the supply chains which we were dealing with, or all supply chains which were global, which had a global setting. They tried actually to have an efficient setting, a lean strategy which is behind it, and the agile setting, which is important once a risk is coming up. That was rather pushed aside since costs were a dominating factor within the global supply chain settings. So this one, both effects in the supply chain are combined together. They cause the issues which we are still facing today with the lead time, with long lead times if you have an order, or different that we might even not be able to find our Christmas gifts. That's what always what's always in the news at the moment. But there are actually solutions for that. So the cause why we face actually the issue is that also during the first phase of COVID-19, we had a disruption of the production. So if we have especially a look at the steel industry as one of the examples, so they reduced the capacities by 40% in 2020, with an expectation that the demand on steel will be reduced also during the whole year in 2020 and 2021 as well. So this caused now a high increase in price for steel, since the demand is was hiking up a lot quicker than was earlier on expected. Then we have like the issues with the freight capacities. I think you all know it. It's already been mentioned also earlier on. So here just an example about the cost of one container. So we had in March 2020 we had a cost, and a container which was costing $1,400 from China to, or from Asia to Europe, and in January 2021 it was like increasing up to 8,000. So we have got here an increase, namely by sixfold. With the new numbers are even worse. So so you have, I mean, not only the price increase, but also we faced delays. So the service level it was quite strongly affected, and you had to adapt the production accordingly. Right. So and then the major part was also, since border closed, and we had these freight capacity, we had sometimes also not container available to transport these items. We actually faced missing resources. The most prominent example is the semiconductor industry, but also in medical, for medical products, we saw that we actually have missing resources, and that's what the simulation is then focusing on. So we built up a simulation service along with DEMCON, along with the Besem Bourbita, who will join me in a few seconds. So we built up a simulation service so that this service enables a rapid redesign of the supplier structure, and hence supports the material availability. So what was the presumption which we were having in the beginning? So we said, okay, there's a extreme high demand increase, and also supply issues. But both of that caused actually a low material availability. So then I have got actually two options if I have this low material availability. So we talked about the lack of preparedness and the limited flexibility earlier on. So here this tool would actually provide you an option to prepare, to have a look out for new suppliers who might actually provide the same piece. The same piece which was like causing a low material, which is where the availability is low. And and you have got the option to actually check with the existing suppliers in case there's still capacity available. So if you just like have a talk with them and ask them what is the or which kind of parts can they provide at what point in time, then that can be integrated here. We have got also transport. We also the part with the that the lead time was increasing or the transport time was increasing. So this is the second string of the simulation part where you can adapt this information which you get from the supplier and integrate that into an overview of the for the supply chain. You can integrate that into the front end, so that the simulation is actually running then in the back part. So that's what's coming now. So you have got the simulation service running in the back part, and integrating actually the information which you gave to the simulation tool beforehand. And the runtime of this simulation tool is 1 to 3 minutes. So we actually paid attention that the simulation tool is running very quickly, because in this part, since information is changing very quickly, then the simulation should run mainly real time. Once you also can talk to the supplier, that you immediately can check the results. So the simulation results then give you information about bottlenecks. So in case you say, okay, in case you have made the right decisions and all the bottlenecks are solved, then you actually can say, fine, that's all, the task is actually done, completed, and you can see, in case you actually looked out for new suppliers, then you can see how to integrate these new suppliers and their lead times into the whole supply chain design setting. So in case there are still bottlenecks available, or if there's still bottlenecks existing, so you want to get which you want to solve, then you have to look out for other solutions and integrate that into the simulation simulation service as well. So this service is providing you in information about the lead times, about the capacity availabilities, and if that's all solving your bottlenecks, the production plan, which you actually which you intended, and hence allows you to evaluate a redesign of the supplier structure. So how does it look now in the front end, and what kind of results do you get out of that? So I have stated here a few input requirements and then also the bottleneck analysis. On the left part, you actually see, first of all, the general information which you have to provide. So there's about some information about the simulation time. So here we had to look at the start of the, so mainly in 2018 we started, since it was still the normal, the year where, so it's covered mainly the year where there was normal operation, and then we wanted to see which kind of effects were coming, which were rising until October 2020. So the capacities which we had were 2 pieces per day in the beginning. So it was like a product which we had here in hand that was only few times asked. So and then Demcon actually started to ramp up the production and allowed then a production of 75 pieces. So the part which, or the product which we had to look at, it's called DemCare. So it's a medical ventilator which was required by the hospitals. So and then we have got here the demand which is entered and the supply chain and parts information which is integrated. Once that is integrated, then the simulation is running in the background, and then we can download again a file which is providing us an overview on the different suppliers which cause a bottleneck and the amount of parts which are actually missing. So we see here on the first part that we actually have 1,300 parts missing in order to enable us to produce everything what we intended to originally. So and then we also see a bit on the on different products which one can actually choose. So you see fulfilled orders which were actually produced for the specific products which are under analysis. Okay, yeah. So in order to give you a bit of an insight, what was the background of this simulation tool and why we actually developed it in a way how we have done it, how I introduced it, I now invite Besem on stage. So Besem is strategic purchaser at Demcon, as we heard earlier, and he accompanied the whole process of the specific product DemCare to ramp it up and to allow the supply chain structure to work so that, that in the end one could actually provide the DemCare products to the hospitals. Hello, Besem.
Thank you for your introduction, Saskia.
Yeah. So, Besem, what is actually so the COVID-19 pandemic, how did it actually affect the production at Demcon?
Maybe it's good to give a a short context, we produce a lot of devices. We are mainly focused on medical devices. I think about 70 to 80% of our production facility is focused on medical devices. What we saw at the beginning, at the start of the pandemic, is that most of the medical devices that we produced, we saw orders fall back to about 50% of the normal production quantities. However, there was one of the medical products that we produced, that's the respiratory system, the Demcon ventilator, that saw an increase of a high increase of demand. We normally produce about 50 pieces per month, but at the start of the pandemic, those quantities increased, or the demand increased to almost 500 pieces per week. So that was quite a significant increase. So we had to ramp up our production, in a very short time, and that came with a lot of challenges. Yeah.
So which issues did you face while ramping up production? You mentioned the challenges, so I think there were actually quite a lot of issues which you really had to face and solve later on.
Yeah. Well, our supply chain was our whole supply selection process was based on the expected quantities during normal times. So me myself, I was responsible for setting up the supply chain for the ventilators, and we selected suppliers that were able to produce the quantities that we needed during normal times. So when we had to ramp up the production almost 30 to 40 times the normal production quantities, we started asking a lot from our suppliers, and they had a lot of difficulties in keeping up with increased demand. But also the capacity levels at the suppliers was subject to external factors. We saw a lot of fluctuations in demand, as I already mentioned, not only from Demcon, but also from other companies that produce respiratory systems. So our suppliers put in a lot of effort to increase the production capacity, but they had a lot of hiccups in ramping up their production. But there were also a lot of supply chain disruptions caused by closed borders, local lockdowns, increasing infection rates at suppliers. So it was very, very difficult to foresee all those challenges, because in many cases they were really you couldn't really expect those disruptions. So that came with a lot of problems.
So how did you actually handle those issues which you faced actually directly in the ramp-up phase? Because it's difficult. I mean, there are a lot of suppliers which are getting into your product. So if I remember it well, there are 70 suppliers you actually have to handle, and they are not all located here in Europe.
Yeah,
so
that's
how did
correct.
you manage?
Yeah, correct. There are about 70 suppliers in total. I think our whole ventilator module consists of about 150 different parts, 150 to 200 different parts. But it was really an ad hoc approach. What we did at Demcon, we put together a dedicated team that fully focused on securing parts. We started with identifying the most critical parts, so the key suppliers for the ventilator module, and we just started securing as many parts as possible. But like I just mentioned, there were also many other companies that were doing the same. So the production capacity at our suppliers was limited, and there were many firms that produce ventilators that had the same approach as we did. So we had a Excel-based tool available at the time. We put that together in a very short time, and that was a tool to keep track of the implications of the fluctuating lead times and capacities of the supplier. But it was really difficult to keep track of all the developments in the supply chain because the bottlenecks weren't fully visible. So also the implications of the high fluctuations were difficult to track. So like I said, it was really an ad hoc approach with the tool available at the time. But we faced we kept facing a lot of problems in case of lead time fluctuations, but also transportation lead times. I think most people remember the first month in China. It was almost impossible to ship anything from China to the Netherlands. Yeah.
Absolutely, yeah. We talked a bit about the setup of the supply chain simulation tool also, as we came together to discuss about your use case. So you mentioned that you used Excel before, and naturally that was like a quick solution because it was just where you had to react very fast. So now that we have set up this supply chain simulation tool, how does it support you in coordinating future issues you would face in case of a ramp up?
Yeah, maybe it's also good to tell a little bit more about the tool that we had at the time, because as we were looking at the supply chain, we had limited visibility, and one of the problems there was that we had a lot of different moving parts. So in an Excel-based tool that was written in a few days, it was very difficult to keep track of all the moving parts and identify the bottlenecks. So we have been working with the simulation for quite a while now. That has been developed by you and your colleagues, and as I just mentioned, we constantly had to monitor the horizontal alignment of all parts, which were all subject to fluctuating lead times. The implications were very difficult to track. So the simulation enables us to almost real time simulate a new situation, and we can identify the bottlenecks in a very short time, so we can act to that accordingly. In that matter, it can really support Demcon or other companies to faster identify bottlenecks in order to secure the continuity of our production plants.
Yeah. So that's what we discussed about in the beginning, and then we said, okay, simulation would be able to. So that's why we actually focused also on this quick runtime of the simulation, so that one can adapt very quickly to the changing circumstances and to the changing information which was coming in mainly in a very on a short notice. Mainly, you mentioned earlier on also an adaptation from hour to hour. So that's what.
Correct. Timing is really essential. It's really essential. It's one of the most important things that when you have disruptions like that, because we were mainly with the key suppliers. We were in contact with them, really from hour to hour, and we saw that their capacity was changing from hour to hour. So we constantly had to adapt to the new situation. And with the tools available at that time, that was quite a challenge. And the simulation really can support one to to do that much quicker. So you can also react much quicker.
Yeah, so we also said, I mean, so we talked about earlier on in the session, in the first session, about this preparedness and also about the flexibility. For that, you need to know which kind of information is actually available, or which kind of events are actually happening. So we also discussed about that in Outlook, it would actually be good to have digital twins, which can then be combined with the simulation. If we can shortly have the slides on again, then I would show you a bit about the here it's coming. So we have got here a supply chain setting. So on the lower end, the operational tasks which have to be fulfilled in a supply chain. Then on top of that, the information layer, where different information systems are integrated. And then it's coming along with that, we have the financial layer for the complete supply chain setting, also important during COVID times. And we see on the right part there a small set on the quality, it's shadowed supply chain. So it's mainly an abstract of the information layer, which can then represent a simulation, or represented by a simulation to test different scenarios. So so mainly the part below, we have got the physical layer. Then we have the information layer, and this is important here. So we have got here the digital twin, or once this information is collected all over the supply chain, then we have got here a digital twin which can provide real-time data and also shows the connection between different data systems. And and then again, the supply chain simulation, which can test different scenarios based on a specific discrete data set, which is coming out of the digital twin. So, and then once a solution is found with the supply chain simulation tool, then the scenario, then the solution can actually flow back into the digital twin, can be implemented into the supply chain, and is getting into it's reaching then also the physical layer. So that's a short introduction also to what we see, how we can even improve the simulation, and to recognize risks which are coming up on a very early stage. So here a question now to Besem, but also in case the audience has got some ideas here, please integrate your comments. But Besem here, which kind of information would you require to be in the digital twin in case you set up, you want to evaluate your supply chain, and specifically also to use the supply chain simulation tool which we developed?
It would of course be amazing if we would have this this digital twin with all the real-time data from the real world translated to some kind of information layer. Is it possible maybe to bring back the slide again? I think that's also helpful for the audience. Thank you. That would of course be great. We can think about the scope. What should be the scope? Would you restrict it only to for example, first-tier suppliers, or would you also go back to second, third, or fourth-tier suppliers? Some kind of digital twin would of course really increase the supply chain visibility with all the real-time data available. One of the most important things I think is to have visibility about the capacity at the suppliers, and the transportation lead times of all the transportation capacities between suppliers, first, second, third-tier suppliers, and between suppliers and Demcon directly. For me to give an example, we have one of our suppliers of die-cast parts in China. They were able to scale up their production, but their production was limited to to a certain amount, that was exactly the amount that we needed weekly. So they were able to scale up, but then we faced the next bottleneck, and that was transportation delays in China. So that was quite a surprise for us at the moment. Back then.
Yeah.
And we identified that bottleneck, and we found a solution. We got help from the Dutch government. They set up an air bridge between China and the Netherlands for us to secure the parts on a weekly basis. So we were able to reduce the lead time from about 8 to 10 weeks to only a few days. So that was really helpful. But if we could have that, if we could have that digital twin in in a much broader way, then we would be able to identify those kind of bottlenecks much earlier. So I think it
absolutely.
would really
So
help.
this is one. Sorry that I interrupt there, Wissam. I just need to have a look at the time also. So this is important to have actually the real-time data available, the different information which is flowing in. I refer here shortly to a project which is now going on in Germany. It's called Catena X, which is specifically having a look at how the information can be shared in order to also facilitate early information and exchange between the suppliers, also to the further tier level. Okay, and that's I thank you, Basim, for joining me here. That's where I actually hand it back to
Thank you for having me, Saskia.
Christian, thank you.
Yeah, thank you, Saskia. Thank you, Besam. I also have some question regarding that topic, which is quite interesting. But before, I would also invite to join our group. I would invite Elena, and I would invite Beatrice again. So welcome back. You have seen now a lot of topics we are dealing with, a lot of results we have achieved in regards to supply chain, especially resilience of the supply chain. And we also got some questions, we have seen that in the first presentation of Elena during the first poll, there was this lack of preparedness. So the question to Elena, or maybe also to the others, if you would like to add something, is so how can this resilience already be introduced in a proactive way when looking at the design phase? So what possibilities do you see there?
Okay, and as I said, I think the resilience starts in the design. The design of the product and the design of the supply chain, the process. For example, if you are thinking when you are designing a product and you are thinking in a material, in a component, before going ahead, and you need to think about the suppliers. What are the suppliers? There is a dependency on the suppliers. There is a dependency for the regions. There are substitutes. We can change to a different component easily or not. This is the kind of question that you need to think in the design phase, or also we are going to put our facilities, the factories, where are going to be, what is going on around. If we decided to go ahead, but at least we know what's going on and we can be prepared for that. And that is the moment to define like a business continuity plan, to be ready, or to identify, to decide it, an incident management, and if to identify different scenarios, and if this happens, what we are going to do. We are prepared for that because we know in advance we are the risk that we are facing with the design, with this product, and with the design of this supply chain. Any supply chain, any product have specific risks, and if we identify them in advance, we could be ready, prepared by deployment with the continuity or with an incident management plan.
Yeah, I guess also, I mean, we heard from Beatrice in the beginning or in her presentation that the process for the mask was built in a way that we don't need suppliers from outside Europe. So Bessem now told, okay, in the beginning there was a big difference or difficulty to get pieces from China to Europe. So Bessem, if you compare those products and look into your own products, how realistic is it that we can get rid of suppliers outside Europe? And if yes, how fast could that be the case? You're mute, so you need.
Can you hear me now? Okay.
Yeah, perfect.
Sorry. So your question is, how easy is it to get rid of a supplier outside of Europe?
Yeah.
Well, in this case, this specific case, it was really difficult because the Chinese supplier that I mentioned is a supplier that provides us with die casting parts, and the molds were only available in China at the time. So you should really have to prepare for that. Yeah, I think that the pandemic surprised us all, and we didn't really have the time to manufacture another mold in Europe on a very short notice. It was very difficult. So that was the case. But I think also our second and third tier suppliers, they are located, or many of them are located in Asian countries. For example, we had one of our second tier suppliers that produces components for us. Their production facility is in Malaysia. So it's very difficult to change the design on a very short notice. The complete software is written on that specific component. So yeah, we didn't really have a possibility to make changes there. But I agree with Elena. You should consider those things when designing a ventilator. You should assess that risk, and there should be a backup plan, a continuity plan. Yeah.
Okay, I can assume that's not that easy, as it sometimes sounds like. Yeah, so I guess that's also the reason why you joined this project, to be prepared.
Yeah, but it's also really something that we didn't think about. We were just designing a ventilator, not considering that we would have a pandemic one day. So yeah. I think if we would design that same ventilator again, we should approach it a bit different.
Yeah, understood. Yeah. So we have heard, and that question goes, I guess, to Saskia. There is a question from the audience. You referred to digital twins in the supply chain. So, and the question or the remark was that digital twins normally represent a machinery process line or a whole factory. So are you also considering a digital twin for the supply chain explicitly?
Yes, so mainly the digital twin is originating from the production side, and then to reflect actually the manufacturing machine and process lines. But naturally, all this information can also be integrated on a supply chain level if it's existing already within a company. So and then we come up to a digital twin which would then reflect the complete supply chain, and that's the intention which is there. If it's really named then digital twin on a later stage, that's still a lot in discussion currently, and that's why I also paid attention that I give a bit of explanation what I mean with that, and that we also pay attention that the supply chain simulation is such is needing a certain set of data from the digital twin then, and does not reflect the digital twin as such.
Okay, thank you. I hope that clarifies the question. And with respect to the time, I have to Beatrice one last question. You refer to supply chain risk analysis, and what we have seen it in the beginning of the pandemic, we missed masks, we missed ventilators, so there was a shortcoming. Then we had a shortcoming in antigen test kits and so ever. And then in the mid of this year, there was a lot of masks available, a lot of test kits available. They were sold for little prices, and now it changes again suddenly. So if you look at this at least in Germany, Austria, we can see this development. So how could this risk analysis prevent those situations in the future? So what kind of support could you give to that?
Well, you will see how the forecasting, the demand is changing, and your risk analysis and your supply chain risk mitigation analysis will include some, or should include some sort of, what are you going to do when those match of the supply and the demand doesn't match, and with that you will have plans of how to do, what to do with that overstock that now you have and you cannot give an exit to. So that's one of the things that your supply chain risk management will be including.
Okay, and yeah, I guess this we will also then try to implement this use case in the coming months of Coversatile. So for today, I would like to thank you all for being part of this webinar, for presenting the results of the first year of Coversatile, and yeah, thank you again.
Thank you, Christian,
Thank you.
for
Thanks.
guiding us.
Thank you.
So, and dear audience, this was the second webinar of our series in this November-December. As you can see, half of it has been happened now. So the coming week will be December 2nd. We will talk about scale up of production. This will be moderated by my colleague, one of my colleagues here from Innovation Hub in Darmstadt. And then we will meet again on December 9th with the workforce ramp up, and that will then close this series of webinars in the first year, after the first year of Coversatile. I would also like to announce that, of course, for 2022, we are already planning to have another series of events, and that is not only related to webinars, where we promote our results, where we give some insights, but we also want to actively engage with you. And for that, we are currently planning a so-called Matchathon event, which will happen in spring 2022. So if you want to be informed, so follow us on Twitter or LinkedIn, keep track on the website where we announce all the latest news and events. Before coming to an end, I would also like to thank the organizing team of this webinar series here from the Innovation Hub of EIT Manufacturing in Darmstadt, but also from the entire Coversatile team. I would especially thank Elena Leinemann, our communication manager, for organizing all those webinars and preparing it accordingly. So thank you very much to the team. And with that, I would like to close this second webinar. I wish you a nice rest of the week. Stay safe and stay healthy. And then we will see us again in the coming week. So thank you very much.